Hello everyone, welcome back. This is Gowda.r studying at Sri Venkateshwara College of Engineering, Bengaluru. Today's session is going to be confidence limits for unknown mean under the subject mathematics tree. So let's get started. Confidence limits for unknown mean. Confidence intervals are a statistical tool used to estimate the true value of an unknown population parameter, such as the mean. By constructing a confidence interval, researchers can quantify the uncertainty around their estimate and make informed decisions based on the available data. In this presentation, we will dive into the key concepts of practical applications of confidence limits for an unknown mean. Introduction to confidence intervals. What are confidence intervals? Confidence intervals provide a plausible values for an unknown parameter based on a sample of data. They are used to quantify the uncertainty around a point estimate, such as the sample mean. Interpreting confidence levels. The confidence level, typically 90%, 90% to 95% or 99%, represents the probability that the true parameter value falls within the calculated interval. A 95% confidence interval, for example, means there is a 95% chance the true mean lies within the interval. Importance in decision making. Confidence intervals are crucial for making informed decisions as they provide a measure of reliability and precision of parameter estimate. They help researchers and decision makers understand the potential range of values and make more information choices. Assumptions for confidence interval estimation. Normality. The population from which the sample is drawn must follow a normal distribution. This assumption ensures the sample mean follows a normal distribution, which is a key requirement for constructing valid confidence intervals. Independence. The observations in the sample must be independent for each other. This means that the value of one observation does not depend on the value of another observation. Known or estimated variance. The population variance must either be known or can be estimated from the sample data. This information is used to calculate the standard error, which is a critical component of confidence interval formula. Constructing a confidence interval for the mean. Step 1. Calculate the sample mean. The first step is to calculate the sample mean, which is the average of all observations in the sample. This provides a point estimate of the unknown population mean. Step 2. Determine the standard error. The standard error is a measure of variability of the sample mean and is calculated based on the sample size and estimated or unknown population variance. Step 3. Choose the confidence level. The desired confidence level, typically 90%, 95% or 99%, is selected based on the level of certainty required for the particular application. Step 4. Calculate the confidence interval. The confidence interval is calculated using the mean, standard error, and the appropriate statistic for the chosen confidence level. Interpreting confidence intervals. Point estimate. The sample mean is a point estimate of the unknown population mean. It represents the single best guess based on the available data. Interpretation. A 95% confidence interval, for example, suggests that if the sample process were repeated many times, 95% of the resultant confidence intervals would certain the true population mean. Confidence interval. The confidence interval provides a range of possible values for the true population mean based on the chosen confidence level. It reflects the uncertainty in the point estimate. Uncertainty quantification. Confidence intervals are a valuable tool for quantifying the unnecessary association with the estimate of population mean, which is crucial for making the informed decisions. Let us now know the factors affecting confidence interval width. Sample size. A sample size increases, the confidence interval width decreases, indicating greater precision in the estimate of population mean. Population variance. A larger population variance leads to a wider confidence interval, as there is more uncertainty in the estimate of population mean. Confidence interval. Increasing the confidence interval, example from 90% to 95%, results in a wider confidence interval, as the range of plausible values for the population mean becomes larger. Selecting the appropriate confidence level. Application specific. The choice of confidence level depends on the specific application and the level of risk a researcher or decision maker is willing to accept. Considering consequences. The consequences of making an incorrect decision based on the confidence interval should be carefully evaluated when selecting the appropriate confidence level. Balancing precision and risk. Higher confidence levels, example 99%, provide more conservative estimates but results in wider confidence interval, while lower levels, example 90%, offer greater precision but higher risk. Statistical conventions. While 95% is the most commonly used confidence level, or other levels may be appropriate depending on specific context and research objectives. Now let us understand how to calculate a sample size for desired precision. Step 1. Desired precision. Determine the maximum acceptable width of the confidence interval based on specific application and decision-making needs. Step 2. Estimated variance. Obtain an estimation of population variance either from prior studies or pilot sample to use it in the sample size calculation. Third step, confidence interval. Select the appropriate confidence level based on the level of uncertainty required for the application. Step 4, calculate sample size. Use the formula for calculating the required sample size to achieve the desired confidence interval width and precision. Real world applications of confidence limits. Market research. Confidence intervals are used in market research to estimate population parameters such as customer satisfaction levels or purchase intentions based on sample data. Quality control. In manufacturing and quality control, confidence limits help identify whether a process is operating within acceptable limits and detect any significant deviations. Medical research. Confidence intervals are crucial in medical research. They are used to estimate the effectiveness of treatments, medications, or interventions and assess the associated risks and benefits. Conclusion and key takeaways. Importance of confidence intervals. Confidence intervals are a powerful statistical tool that provide a range of plausible values for an unknown population parameter, such as the mean, and quantify the associated uncertainty. Key assumptions and considerations. Constructing valid confidence intervals requires certain assumptions, such as normality, independence, or unknown estimated variance, which must be carefully evaluated. Practical applications and implications. Confidence intervals have numerous real world applications, from market research and quality control to medical research and decision making, and their proper interpretation is crucial for informed decision making. Balancing precision and risk. The choice of confidence level involves a trade off between precision and risk and should be based on specific application and the consequences an incorrect decision. I hope you guys like the presentation. Thank you.